All right, we're looking at answers to review for quiz 8. Number 1, we're looking at absolute extrema of f on the interval from -2 to 5. So first thing we need is to take the derivative, which we did here, and we set the derivative equal to 0. I went ahead and factored out 3x as I did that, which gave me 3x times x minus 4. So when I set 3x equal to 0, that's going to give me 0. And when I set x minus 4 equal to 0, that's going to give me 4. So once I have my critical points, then I'm going to plug my endpoints, which are -2 and 5, and my critical points, which are 0 and 4, back into f. When I do that, -2 produces -27, 0 produces 5, 4 produces -27, and 5 produces -20. So my absolute max value is going to be 5, and it occurs at x equals 0. My absolute minimum value occurs twice, which is -27, so that happens at -2. And I screwed that up. That should have been 4 right there instead of 5. All right, question 2. Take the derivative. So this is going to be a chain rule. So bring the 2/3 down. Inside stays the same. Subtract 1 on my exponent. Derivative of the inside gives me 1. So move the negative exponent to the bottom. So that gives me 2/3 times x plus 2 to the 1/3. Set it equal to 0. Set both parts equal to 0. 2 doesn't have a variable with it, so I don't have to worry about that. Set the bottom equal to 0. I can get rid of the 3, get rid of the 1/3. X is going to be -2. So then I need to plug my endpoints, which are -3 and 6. So -3 and 6. And I plug in my critical point. So -3 is going to give me a 1. -2 is going to give me a 0. And 6 is going to give me 4. So my absolute max value is 4, which occurs at 6. Absolute minimum value is 0, which occurs at x equals -2. Question 3, interval is 0 to 2 pi this time. So my derivative of x is 1. Derivative of cosine is negative sine. Set it equal to 0. Move the sign over, so it gives me sine of x equals 1. Sine equals 1 at pi over 2. Plug in my endpoints, 0 and 2 pi. Plug in my critical point. So I plug 0 in, so that's 0 plus cosine of 0. Cosine of 0 is 1. Pi over 2, so pi over 2 plus cosine of pi over 2. Cosine of pi over 2 is 0, so pi over 2 plus 0 is pi over 2. And plug in 2 pi. So 2 pi plus cosine of 2 pi. Cosine of 2 pi is 1, so that gives me 2 pi plus 1. So 2 pi plus 1 is my biggest value, so that's my absolute max, and it occurs at 2 pi. And 1 is my smallest value, so that's my minimum, and it occurs at x equals 0. Question 4, chain rule on this one. So bottom derivative of the top minus the top derivative of the bottom over the bottom squared. Clean up the numerator, gives me -x squared plus 1. Set that equal to 0. Set each piece equal to 0, the top and the bottom. So the top, I move the x squared over, take the square root. Don't forget the plus and the minus. A couple of us were forgetting the plus and the minus on that one. On this one right here, it's impossible to get 0 out of this because anything I plug in for x here is going to be positive plus 1, and if I square it, it can never be 0. So my critical points are 1 and -1. So my endpoints are -2 and 2. Critical points are -1 and 1. Plug those in. -2 gives me -2/5. -1 gives me -1/2. 1 gives me 1/2, and 2/5 gives me 2. So my largest value is 1/2, and it occurs at 1. My smallest value is -1/2, and it occurs at -1. All right, on the piecewise function, I need to take the derivative of each piece. So derivative of 10 is 0. Derivative of -2x is -2. Derivative of -x squared is -2x. Derivative of 3 is 0. Derivative of 4e to the x minus 1 is 4e to the x minus 1. Set each of those equal to 0. I solve this one, so I add the 2x over, I divide, it gives me a critical point of -1. On this, remember we've talked about it before, e can never be 0, so there is no 0 out of that. And there is one more critical point, which is 1. I have to check where this piecewise jumps from function to function. So I need to plug 1 in here and see if I'm undefined, because if I'm undefined, that can also give me a critical point. So if I plug 1 in here, that's -2 minus 2, which is -4. If I plug 1 in here, 1 minus 1 is 0. E to the 0 power is 1. So that gives me a +4. So I got a -4 up there, +4 up there. So that means my derivative is undefined at 1. Therefore, it's also a critical point. All right. We said the interval, I went back and wrote the interval was from -2 to 2. So that's why these are in here. And then my two critical points are -1 and 1. Plug those in, 10, 11, 7, 3 plus 4e. 3 plus 4e is going to be my biggest value, and it occurs at 2. And my smallest value is 7, and it occurs at 1. All right, question 6. This is where we're using the second derivative test to find maxes and mins. So first derivative, if I take the derivative of e, it's going to be e and then times the derivative of the exponent. So derivative of x squared is 2x. Derivative of -4x is -4. I set that equal to 0. Set each piece equal to 0. Again, we talked about it. E cannot be 0, so I don't get a 0 from that. Set the other piece in there, and we get x equals 2. Then for the second derivative, we're going to do product rule. So that's going to be first times derivative of the second plus the second times derivative of the first. So again, that's going to be e times the exponent, derivative of the exponent. So that's how I get 2x minus 4. Notice I have an e in both of them, so I factor that e out. That leaves me with 2 plus 2x minus 4 times 2x minus 4, which is the same thing as 2x minus 4 squared. Then I'm going to plug in my critical point, which was 2. So I plug in 2 here. So that's 2 squared minus 4 times 2. So that's 4 minus 8. So there's a -4. I plug in 2 here. So 2 times 2 is 4. 4 minus 4 gives me 0. So this piece is 0, which leaves me with just the 2. So 2 times e. Remember we said e is always positive. So 2 times a positive means that my second derivative is positive. And that means we have a relative min at x equals 2 because our second derivative is positive. Because remember, if our second derivative is positive, that means we're concave down. And if we have a critical point on a concave down part of the graph, that has to be, concave up. Second derivative is positive, so we're concave up. So critical point on a concave up piece means I've got a minimum. Sorry, I didn't mean to botch that up there. Question 7. Same thing, derivative. So derivative of 2x cubed is 6x squared. Derivative of 11x squared is 22x. Derivative of -8x is -8. Take out the 2, factor what's left, set it equal to 0. That gives me 1/3 and -4. Take the second derivative. So derivative of 6x squared is 12x. Derivative of 22x is 22. I plug in the 1/3. 12 times 1/3 gives me 4. 4 plus 22 gives me 26. I plug in the -4. 12 times -4 is 40. -48. -48 plus 22 gives me -26. So I've got a relative max at x equals -4 because the second derivative is concave down at -4. And if we're concave down, our second derivative is positive, which means f is concave down. I'm really struggling. And then I'll get a minimum at x equals 1/3 because the second derivative is positive, which means we're concave up and we have a minimum. All right, question 8. I don't have that in front of me. We had h of 2 equaled something. We had h prime of 2, which equaled 0. So since h prime of 2 is 0, that means it's a critical point. And we had h prime of 2 was less than 0, which means we're concave down. So that means we have a relative max. So we have a relative max at x equals 2 because h double prime of 2 is less than 0.